quickly add Jossi on here. Woo, quick turnarounds. Hey, Jossi, how's it going?
Hey, it's going okay. It's super late here, so I'm
Oh,
kind of tired, but you told me to do jumping jacks, and that worked, actually. So, yeah. Well,
look
nice
at that.
start.
This is like almost a who wore it better. I think. Okay.
How's it going?
Uh, it's going great. It's a lot earlier here, so thank you for your time. I think folks are pretty excited to hear your talk. Um, and oh, I'm not sure if the banner is going to pop up, but I didn't have time to post on the channel. There it is. Awesome. John's the best. Right. If you have questions, please head over to the J2 Jossi Wolf channel. It's always like easy to like ask questions as you go along. And of course, we'll take the end of the time to make sure we have some of those questions answered. Okay, so without further ado, I'm going to hand this off to Jossi Wolf, and he'll be talking about experimenting with Kotlin Compiler. Ooh, wow. So this is like a whole Kotlin Compiler and plugin portion of the conference. I love it. I'm actually a huge fan, so can't wait to hear about it. All right, take it away, Jossi.
All right. So, thanks so much, everyone, for joining. As Amanda just said, there is the Slack channel. So, if you do have any questions, please make sure to ask them there. So, today I'll be talking about some experiments that I made with a Kotlin compiler, which were super fun. And I want to tell you what I did, how I did it, why I was being so crazy, and how you can do it too. So my name is Jossi Wolf, and I work at Snap Mobile, and we're this kind of agency slash consultancy, sometimes we're not really sure, kind of thing. So basically, we help companies improve their apps, or we build apps for them. And last year, we had a project, and we were building an SDK, and it was quite challenging because I had never built an SDK before, and I learned like the first thing at first, SDKs should be simple. So what we were trying to build was actually quite complex. Obviously, I can't share any details with you because proprietary stuff and so on, but I'm going to show you an example. So we had this, so for example, you would have a class called chat SDK. And in that, you would probably put all your functionality for your chat SDK. You would want to be able to send messages. You would want to be able to receive messages. You would want to have live updates. You would probably want to have some kind of message deletion mechanism. You would probably want to be able to add users and so on. And things get quite complex so like really quickly. So what you do is you start extracting stuff. So interfaces are really important, right? For everything, building abstractions and keeping things kind of modular. Now, talking is hard, I'm so sorry. So say you are implementing this interface in your chat SDK, right? It's like this real simple thing. You have a mutable list that keeps the messages. And then you override just the methods. Now, something that Kotlin brings with it is this awesome feature, which is called class delegation. So if you find yourself like saying, okay, we have our chat SDK, and we want to build in messaging, but then we also want to add some stuff for user management into the chat SDK, things can get really bloated. So what you can do is you can say, all right, I want to delegate the implementation of this interface to something else. So in this case, we're saying, I want to delegate the implementation of the message feature to the simple messenger, to a new simple messenger instance. And what that does under the hood, this is what the decompiled bytecode looks like in Java, is it first generates a synthetic field, which is named delegate underscore 0 because there's only one delegate, like it's the first delegate. If you were to have multiple delegates, it would be delegate 0 and then 1 and so on. and it assigns it a new simple messenger instance, right? So the same thing that we did right here as well. And then Kotlin generates the method calls for this. So the chat SDK class implements those methods, and it just like delegates all the calls to this delegate field. So this is a super, super awesome and super useful feature for, for extracting things and for keeping your code base clean. And it's very, very helpful when you're building something which has just one entry point. But turns out it's kind of limited. And we hit the limits real quick when we tried to use this, because we were building an SDK that just heavily relied on Android custom views. And with an Android custom view, you cannot have a custom constructor with extra constructor parameters. Even if you provide default arguments, it'll crash. It's this weird thing, but you just cannot do it. And there are lots of other scenarios when you're building for environments where you just simply cannot control the constructors. So we were sadly forced to not use class delegation because it wouldn't work for our use case. But I still sat down a while after and I was like, I want to see why this is not working. And I found a couple of limitations, and I learned a bit about the Kotlin compiler, and that's what I'm talking about today. So first thing I learned, I mean, it's probably you know this, but Kotlin is open source, and every time I see it, it still kind of amazes me because I really like Kotlin as a programming language, and I'm just so happy that it's open source. And that also means that you can just go and you can clone it. You can clone it from GitHub. Super easy. It might take a couple of minutes to download, but then it's there on your machine. After that, you will need to make sure that you got JDK 1.6, 1.7, 1.8, and JDK 9 set up, all in parallel. Kotlin needs that to work. Don't ask me why. But it won't build otherwise. And after that, you can just open IntelliJ and just open the clone project that you had, and Kotlin will be there. It's super nice. It's overwhelming, but you will have like all of the Kotlin programming language right there. And that looks like this then. As you see, there's a lot of stuff going on. But the most important part for us, or for me, when I first opened this was, I want to have something that works, right? So I looked around and I wanted to run it first. So there are a couple of run configurations that just come with the Kotlin open source project. If you click on that drop down in the top right next to the run icon, you can see all your configurations, and there are a couple of ones, and the one that we really care about is the IDEA one. So what it does is it runs this Gradle task run IDE, and that basically compiles all of your sources from the Kotlin project, and it packages them into a plugin and launches an IntelliJ IDEA instance with that injected. So you get like just a new IntelliJ instance with your code right in there, which is fascinating. So that looks like this. It's just another IntelliJ instance. You can create new projects. You can check out existing ones to see if they're still working with newer changes or something. What you can see here is that I have my IntelliJ that I'm launching when I'm building stuff in light theme. This is super important for me to distinguish, and I would really recommend having two separate themes between IDEs that you're working in if you're working with multiple instances. So as I said, I did stuff with the Kotlin compiler. And what does that even mean? So I didn't go to uni or anything. I just started working straight out of school because I thought it was fun. It's still fun. But when you're like looking at compiler knowledge and how people got compiler knowledge, it's probably mostly that people will have had compiler classes in uni. And there are a few people who, you know, come to compilers on their own. So I was kind of blindsided, or pretty blindsided. And if you have never heard anything about compilers before and how they work, that's totally fine. So I just want to give like a real brief intro to say these are the basic parts that we're going to be looking at later. So generally a compiler, right, is something that takes an input, in our case, a Kotlin file, and it compiles that into target machine code. So that's bytecode, native code, or JavaScript in Kotlin's case, because it's pretty awesome. And more generally, a compiler, like, what does it consist of? So compilers consist of multiple parts, and it's never always the same. It's not always the same. But looking at the Kotlin compiler, there's kind of three parts that we can find. So number one, that's the lexer. So the lexer takes the input, just like the raw input, and it looks at the text from the source file, and it classifies that into tokens. It looks if that's like something it recognizes, and if yes, it basically adds it to a list. Second stage, there is the parser. So the parser takes that token information from the lexer and does some exciting work with it. So step number one is there's a syntax analysis going on. It takes all the tokens, it looks at them and looks, is this syntax okay? Can I work with this? Can I analyze this properly? Or are there any errors like off the top of the butt? And from there, it creates an AST. So AST stands for Abstract Syntax Tree. And it's this concept which represents the input in a tree. And it's very, so as the name says, it's abstract. So it does only contain information that's actually useful for, for actually compiling the code. So that means if you had code like this, where you have a function parse, and it has two annotations, and then there's a line comment between, what the AST would look like is this. So you would have the class declaration for your function and then the annotations, but it doesn't actually care about things like comments and so on. So it's only things that are actually relevant for the grammar of the language. Now, it's totally fine if you're like, still, what the heck is an AST? But this is like some useful info for later. This gets passed to a semantic analyzer, which then runs some more analysis, which is not as important for now. And then final stage, there is the code gen. I briefly want to mention the PSI, but we're going to take a look at that later as well. I'm sorry if it feels super overwhelming and things are going to come later, but don't worry about it for now too much. I also want to mention that there's a super awesome GitHub repository. Actually, Amanda made it. It's the Kotlin Compiler Crash Course repository, and I linked it at the bottom of the slides, and I will post the link in Slack later too. Definitely take a look at that if you're looking to get to know more about the Kotlin compiler's workings and so on, because it's quite confusing, as you can see, and it takes some time to get like a proper grasp of it. I would really recommend checking that out. So we didn't properly look at the code gen phase yet. Let's take a quick look. There are two basic things that are happening. First, there is the intermediate code generator. So basically, it takes all the input from the parsing phase, and the intermediate code generator generates a first internal representation of the code, what it would look like. This is not optimized, and then finally there's some code optimization going on, and that's kind of like the last stage before you would get code out to any real machine. So generally, these can be divided into two parts: the front end and the back end. If you take a look into the Kotlin repository, you will also see these are divided into front end and back end packages and modules. So this has been tough so far. I know, I'm sorry. Well, actually, you should go to the Kotlin folks. It's their fault. But here's a cute dog picture to hopefully make it up to you a bit. So that was a lot. We looked at compiler kind of basics, and we looked at why I even wanted to do this project, right? So we had this work project, and it was just, I really wanted to use class delegation, but I couldn't. And I was very interested in looking at, well, why is this not working? I really wanted to know. So I decided to take some free time, take some evenings. I thought like 1 or 2 or 3 evenings, and look at why it's not working. So just to recap, class delegation is this thing where you can say we have this interface, for example, message feature, and we want to delegate it to this instance. What I wanted to do was I really wanted to be able to access class members from this constructor up here. I really wanted to be able to say like by messenger and not only be able to define it up here or in the constructor. So I dug around and I found this keep. So a keep stands for Kotlin Evolution and Enhancement Process, and you probably have heard it. There's a couple of like big famous keeps which gained a lot of traction. Basically, this is the place where you can submit a proposal for the Kotlin programming language if you want to see something improved or if you want to see something changed. So I found this keep, and it had gone stale. So the way keeps work is you head over to the Kotlin Lang Slack, you sign up, and there's this channel for language proposals, and you post in there and you talk to other folks who might have similar ideas or who might have input. And then if someone else thinks your idea makes sense, and if you have discussed it a little, you can open a pull request to the keep repository, which is what this person, Decode Donor, did. So after you open the pull request, you can get more input and more visibility on the keep. You can get, just more feedback from others. And you will wait for a shepherd to take your keep on. So a shepherd is someone from JetBrains who looks at the repository and just works on Kotlin and will basically take the issue up as priority internally at JetBrains and then start working on it and start coordinating the work. So this keep had gone stale and no shepherd was found ever. It's such a tough process to properly do, and lots of keeps go stale. Sadly, this was one of them, because class delegation is not exactly a very important feature for a lot of people. So I was like, okay, I can either reasonably contribute and try to revive this keep, which I tried for a bit, but then I didn't want to spend that much energy on it. And I was like, okay, I could also just go and experiment with a Kotlin compiler. Sure, let's do that. So one of the proposals in the keep was to say, all right, we can mark properties or members. We can mark them as class delegate, and that way we can make sure that we can access them. That way we can make sure that we can access them from this constructor scope. So that's what I wanted to try. The nice thing is that this enables you to do awesome things like swapping the implementation later on, and doing other really nice things. So looking at this code, looking at class delegate, looking at kind of this proposal, I noticed that it looks similar to something, which is late in it. I felt like this is just like a gut feeling, like, hey, this feels kind of different. It feels kind of similar in terms of just what it does. And I looked around a bit, and so late init is a modifier, just like you would have private or internal or public as visibility modifiers. Late init is also a modifier on properties and variables. And so class delegate also acts as a modifier. It modifies the behavior of a property, which is exactly what we want. So I had my first kind of starting point, which was like, how do I want to add a modifier, and now how do I do that? So first instinct in a code base that you don't know, that's looking around. So I always CMD, shift, and effing. And I was really desperate. I just looked for late init. And there was lots of results, over 100 matches in 42 files. In a code base that you don't know, that's a lot. But I kept looking around, and eventually I found this file, which was called kttokens.java. So basically in there, I found like a huge list of just all the tokens that are just available for Kotlin and that are available for the Lexer. That's where you get back to, oh, this is why we looked at this. So it's really this huge file. It contains every keyword. And as you see, there's the late init keyword. And it's an instance of KT modifier keyword token, which is a very simple Java class, just a model. And it's a soft keyword modifier. And we don't have to care about what soft keyword is or a keyword. The difference is not that important for now. I started out not knowing what a soft keyword is compared to a keyword too. And what I did was I just added this class delegate keyword property. And I said, okay, it's a soft keyword modifier. And like the modifier's name is class delegate. And now I could write this code with, it would compile and it wouldn't like fuck up the compilation, which is nice. Obviously, my happiness was short-lived since it didn't do anything, right? So it was just, it was just there, pretty boring. So what I wanted to do, right, was access this. This was still not working. And since we kind of hooked into the lexing phase, I thought, okay, how the hell do I go about this? So I learned that this is the constructor header. You might know this already, but if you don't, well, sorry. So I learned that this is the constructor header. And I looked around a bit for how does kind of the resolution actually work? Like, why does this tell me it can't access that? And what I found is this file, which is called bodyresolver.java, and it basically takes care of resolving everything within the body, which also includes this. So I found this line, which was just assigning a lexical scope for resolving some members. And the lexical scope basically is something saying, all right, this is the stuff you can look up, or this is the stuff you know, this is the stuff, this is some other stuff you know. So you might have a lexical scope for the constructor, you might have a lexical scope just for a function, right? It basically provides some context for what is going on in terms of members and properties and things that are symbols that are available. So I found this line, right, and it says like scope for a constructor, if that's null, use the scope for member resolution, otherwise use the scope for constructor. And I thought I could be smart. Well, not smart, but hacky. And I could just say, all right, the scope equals the scope for a member resolution. So it would always pick that, and it would always make things from the body, from the member resolution, available in the constructor. Now this was kind of weird since I was just digging around, and it took quite a bit of time. But after, I guess, a couple of hours, I found this and tried it. And ta-da, turns out it worked. Like, I know this sounds super, super crazy, but it actually worked. I'm not going to say like that the underlying code was nice, but it didn't crash. It compiled. It worked just fine. I could use my code. And that was like a really amazing moment, because I had never done Kotlin compiler stuff before. And by that point, I had spent so many hours just trying to find my way through the Kotlin compiler. And I did it. It worked. So I want to take a quick look at what the heck was actually going on there. So this right there, this whole thing, this is the primary constructor. Now, you might be like, okay, yes, I know this is the primary constructor, but maybe you don't exactly always know like how is something represented within the language. And so within the compiler, you might not always know what does it mean. So there's this really handy tool which allows you to view the PSI structure of a current file if you're running IntelliJ IDEA in debug mode. So right now, this is when you, from the Kotlin, if you open the Kotlin source project, right, in your local IntelliJ IDEA instance, and then run the IDEA task, you get this IntelliJ IDEA instance, and you can go to Tools and view PSI structure of the current file. And it'll display you something like this. So as you see, there is this, it's a dummy file. There's the package directive, which is empty. There's the import list, which is also empty. Then there's the class marker, which is this interface. And then there's another class, which is this chat SDK. And then if you look at the chat SDK code, you can you can click on symbols and it'll highlight what it is. So in this case, like this empty constructor, like it tells me like to Kotlin, to the compiler, this is a primary constructor. So if you are ever looking at stuff and you're like, okay, how's this represented within the compiler? This is what you probably want to look at to find out and go from there. So now I knew, okay, there's the, we have the primary constructor. And I looked around a bit in all of the code generation stuff because I knew, okay, I did some things with the lexical scope, which has to do with resolution. I did some stuff with the lexing. The only part I didn't touch yet is the code generation. So I found this file, constructor code generation.java, and looked into it, and it was quite big, but still readable, which was nice. And in there, it turns out there is this method which is called generate primary constructor, and it does exactly what you think it would do, right? It's responsible for generating everything related to the primary constructor, including generating everything that has to do with class delegation, if that's there. So just a reminder, this is what the decompiled bytecode looks like. You have a synthetic field. So that's a field that is generated by the Kotlin compiler. It's called delegate_0, and it's just assigned this new simple messenger instance. So let's take a look at this constructor code gen and what is going on in there. Step number one, it generates the delegator calls. So for each specifier in the super type list entries, it goes through that. So the super type list is after the call-in, right, the list of super types where you might have message feature by messenger, maybe you will have comma user feature or something, right? So that's a super type list. So it goes through that, and then it looks like, is that an instance of the KT get delegated super type entry, right? So this would be a KT delegated super type entry, and that's something to act on for it. And then it calls this method generate call to delegator by expression specifier. So in our case, the expression is messenger, the delegator is this whole thing, and it generates the calls to the delegator and to the delegate with that expression. Now, second thing that comes up is generating the fields. I know this is like a lot, and you don't have to like grasp the whole code. Just to show you kind of what's behind it. So it also just goes through the list of all of the primary constructor parameters, and then it generates fields within the class for that. Third thing and last thing is it generates member initializers. So up until now, nothing in there had been initialized. So it had generated a synthetic field, right? Like it had generated a synthetic field, delegate_0, but there wasn't any initializer, and that's what it does last. So that's kind of the rough order of things that happen in there for class delegation actually to work. And I was like, okay, it's kind of a shot in the dark, but what if I actually just, try swapping things around? So I did. So what I did was I generated the fields before generating the delegator calls. So let me go back a couple of slides to one specific code sample, if I have that somewhere. So sorry. So, wow. See, I've totally forgotten where I'm. Okay, so this is a delegator call, right? So what it would do first is, first it generates the delegator calls, then it generates the fields, and lastly, it initializes them. So what I thought of doing was just, trying super shot in the dark, just to swap it around. And turned out, bear with me while I skip ahead like 10,000 slides. So it turns out that was actually working. We'll be there in a second. Already 10 seconds. 320. So it turns out that was actually working, generating the fields before. And to be honest, like, I still cannot be like, oh yeah, this is exactly the line where things happen. But this code was actually working, and everything was working even when I compiled stuff. Because just I swapped some lines around, I made some very weird hacks and adaptations to the Kotlin compiler, and it worked. So this is what code would look like at the end. Right. So you can see that it references like the messenger field, which is, so it's still a synthetic field, which is generated. I just assigned it a clearly readable name right here. But you can also see that it has setter methods and it has getter methods for that field. And then the delegator calls just always reference that delegate field. So that's actually what made it work. Right. Now, I know there's a lot of stuff, and a lot of those things were probably super confusing, especially if you had never looked at the Kotlin compiler before. So basically, the lesson that I really want folks to take away from this is experimenting with the Kotlin compilers was such a fun lesson for me. It was a really nice side project from my, Android day-to-day work where I was doing lots of UI, and it was very nice distraction. It was something which I totally did not know anything about, and I learned so much. And I still probably know nothing, but I learned a lot. And it was really fun experimenting just with things. And then there are so many awesome folks in the community who also help a lot and are so nice about trying to make you understand how things work. And I would really, really recommend anyone just to download the sources. It's, probably takes a minute or two to download them, and then build the project. That probably takes like 20 minutes, but still, and just run it and maybe modify some code, baby steps, but try it because it's so much fun once you actually get to see that you changed something in your day-to-day development language that you are using at work probably. So yeah, all of my hacks, adaptations, whatever you want to call them, I opened a pull request in my for Kotlin repository. So you can go to this link, which I'll post in this Slack as well, to see the diff and look at the files that I changed for this to work. You can also pull the branch and build it and experiment around with that. And it was a super long talk. So here's another doc picture. We're almost at the end of the slot. So if there are any questions, I'll be super happy to answer them right now or later in Slack. So thanks so much for listening. I hope you all will have a great rest of the conference.
Sorry about that. Thank you so much, Jossi, for sharing. I believe we do have some questions. I just have to, hold on just a sec. Here we go, the first hitch. I've been, I'm like panicking. I cannot find your, here we go.
There is no
Okay,
questions.
this is,
That's good.
yeah, there should be some questions. I just cannot for the life of me check where you're.
That's fine though.
Oh, I found it. Sorry, I'm having a little bit of internet issues. So if I cut out for any reason, okay,
That's fine.
cool. We'll start off with a question that I have. What would you say was like one of the most surprising things you found when going into the Kotlin language and the Kotlin compiler?
Like one single thing? Well, I was really surprised like by how big the whole thing was and like of how many parts it consisted. And I think like the other kind of big thing is I was very surprised by there being not really a lot or any of documentation and basically no code comments. That was harsh on me. Like not finding a lot of resources. But then again, like finding this huge code base and that it worked, I think that was like the single most amazing thing I've ever seen so far. Yeah.
Would you say that you'd be looking to like work with more like compiler plugins in the future? Are there any other like ideas that you have?
Yeah. So I definitely want to like keep hacking around with a compiler, even like knowing that my code isn't production ready or anything. But still, I think it's super fun, and we've been experimenting with use cases for compiler plugins at work. So I'm always like looking for ways to push it into my day-to-day work. So I think compiler plugins and working with things like Arometa could be a super nice chance or like a first step to doing compiler work if you don't want to go like all into a mostly undocumented code base, like head in first.
And I guess given that, you know, it's not, I think it's unique that developers are able to take a look into an open source language like Kotlin and then just be able to literally start putting their hands in the spine and just start really messing with things. What would you say is your perspective on where Kotlin is going in regards to development with compiler plugins?
It really feels like they've been, so I know they've been doing a lot of work under the hood. They've been improving code really, and they've been improving APIs. I think especially things like Jetpack Compose show that the JetBrains folks are actually willing to listen and to make changes and improve their code and improve kind of like hooks into the compiler. And I think that especially like compiler plugins do have a great chance of becoming more popular and maybe adding just very business. If you have a company, you have a very unique use case, right? I think compiler plugins can be such a great use for that if you're a bigger company and you're reusing things across multiple projects. And they definitely seem to be headed towards that. So that's a nice thing to look out for.
Okay, yeah, thank you. Super exciting stuff. I think we'll give it another couple seconds for any additional incoming questions. But I have to say, super impressed with the presentation, especially since I did spend some time looking into the Kotlin compiler, and I personally am super excited to see that someone is able to build on existing work, because right now there's not a whole lot of documentation out there, and I certainly hope that you'll be looking to contribute some of this knowledge to other repositories. It could even be the little crash course thing, but I think The Kotlin compiler is like super scary. There's
Yes,
no
it is.
documentation. Um, but I think this is it. I just love seeing that other people are getting into it. Okay, super great talk. I think we're going to just maybe cut it off here so we have a couple minutes. I know we kind of did a back to back. We actually have until 2:50 for the last talk of the day. Jossi, thank you so much. We really appreciated your talk. Please like post any of the links that you were talking about. Like in the attendees channel or even your own channel. And I'm sure, folks, please feel free to DM Jossi if you have some like really in-depth questions and whatnot. Okay, thank you so much. We'll be right
Thank
back.
you.
All
Bye.
right, thank you, Jossi.